Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue looking at our example of a networked game, and we're developing a game of Tron. So we started last time, we laid out the first two steps of the process of making an application use RMI. We made our remote interfaces. These are completely abstract traits for both our client and our server. And then we declared some objects that extend these. I should note explicitly, while in every example we've done so far, we've been able to make it so that the things that were our implementations extended the object type. This is actually kind of rare. Most of the time you'll want these to actually be classes that you can instantiate. And so in this video I want to work a little bit on the implementation of this. How are we going to make this so that it works? Well, on the client side, we need to have a frame and a panel. So we'll go ahead and create those. We'll make a new mainframe. Contents equals panel. I'm going to go ahead and do an underscore import for everything. So the panel is a new panel, and we will override def paint. With only 2 R's instead of 3. Preferred size. This is the one place where I question the way that I'm thinking about doing this. We'll go ahead and hard code in a 500 by 500. But in the goal of avoiding magic numbers, you'll see why these magic numbers might pop up occasionally. So what's going to happen inside of here? Well, we're going to draw an image as 0, 0, and null. So this image is going to take up the entire space. At least that's how we'll start off with this. We'll probably add something else in just a bit. Image equals image is of type buffered image. We're going to start off as null. And the reason for doing that and for making it a var will hopefully become more clear in just a bit. Okay, so we have that, and inside of our main we can open the frame. It's worth actually running this to make sure that it will pop up. Oops, I'm not centering on screen, so it'll pop up over here in the corner, and sure enough, there we have it. And it's very boring because our image is null. So let's go ahead so that things do pop up centered. Now, the other thing we have to do is we have to get hold of the server. Okay, so that means we need to jump back here to the server so we can have a server that we could get hold of. And I am going to come into here and I'm going to pull out these 2 lines of code from the main over there. So we want to locate registry and create a registry at the default port. And let's just call this object the Tron server. And then over here, after we've opened this, let's do a interesting. Open that dot lookup, and once again we give this a string for it's a URL. We can start it with RMI : // Turns out if you get rid of the RMI : it'll figure it out because you're doing an RMI connection here. We give it the machine name. If we were writing this in general, I'd probably actually want to do something like a dialog and pop up a thing that asks you what machine you want to connect to. To keep this simple for the sake of the video, I'm just going to say, hey, we're starting it off on localhost. And we're going to look up the Tron server. After we've looked it up, oops, and we should go ahead and do server equals, we do the lookup. Now, as you might recall previously, the problem here is this just knows it gives us an RMI remote, and we need to specifically have a Tron server. So I'm going to match this to a case of a Tron server, in which case it's going to give us back the server. In the case of anything else, we're going to throw a runtime exception, invalid type for RMI server. Okay, and so now our server is a Tron server, and we can do something like val player number equals server dot connect, and we pass it this, the current object. Okay, so this will make the client so that it calls connect onto the server, which of course returns 0 right now, and we could even print that out. Now we have to run this. We have to run a server now, because if we run the client without having a server up, it doesn't do anything, or it will crash, and you'll see it print 0 because that's what our server is returning. So I kill the server. Okay, that number is going to be a unique identifier, and so we kind of need to know what's going on here. This is, we get something interesting in this situation. It turns out that the way that the RMI works, the RMI calls are happening in a multi-threaded way. So it's tempting to do something like this: private var num players equals 0, and then to num players plus equals 1, and give back num players minus 1. And why is this not found? Value num players, reassign it to val. I don't see why that should be the case, since this is a var. Do I have a typo someplace? And it recognizes it here just fine. Oh, it, capital P. There's the typo. Okay. So technically, this is probably very safe in most situations, especially for our simple little example. But this isn't thread safe, because if two clients call close enough together, this would cause problems. In addition to that, we also wanted to only have it so this happens if num players is less than 2. Then we want to do that, else I want to give back a -1. Also, they passed in a client, and so I need some way of storing clients. Private var, we could do this with a buffer, and so we can make it a val. Mutable buffer of Tron client, call this clients, equals that, and let's put in our import collection dot mutable. Okay. Control Shift F to format that. That will do that. And actually, before we do the increment, let's go ahead and do clients plus equals client. So we throw this client on there, and in fact, in some ways now you can say, hey, this is completely superfluous. I don't need that because I have a length here. Clients dot length is less than 2. We add to the clients and we return clients dot length minus 1. Okay, but this adding into a buffer, so the problem here is if you get interrupted and two people connect close enough together in time, this can be a problem. So this is the one operation that I really have to be careful with here. So I want to synchronize it. I'm going to synchronize this on clients because this is checking a value on clients and it's mutating the value on clients. I want to make sure that this can't be done by more than one connection at a time. And so now if we rerun our server and then connect with a client, I get this one is number 0. Now that's the same answer we got last time, but if I do it again, this time I get number 1. Okay, so now we have clients, one client that is a number 0, one client that is a number 1, and our server actually knows about them because that is sitting in here. So what we're going to do in the next video is come back and start making this interactive and start working on how we get the client to draw things.